Hello and welcome to MongoDB Quickstart with Python. MongoDB is one of the most popular and exciting database technologies around. Python is one of the most popular and fastest growing language there is. And these two technologies work great together, and that's exactly what this course is about. So we're going to quickly get started with MongoDB, write some code against it, and build some realistic applications. So the goal with this class is to teach you MongoDB. We assume you know a little bit of Python, but you'll of course pick some things up along the way if you don't know it already. And really, we want to get you going quick, hence the name Quick Start. So let's get started by talking about what we're going to cover in this course. We're going to focus on three main things. We're going to start with why do you care about NoSQL and document databases? How do document databases make working with schemas easier, modeling data easier, as well as add performance and flexibility to our applications? We're going to talk about modeling specifically because this is one of the things that is pretty challenging about document databases. If you come from a relational database world, you probably know about third normal form. This is a way to carefully and sort of structured way to plan out how you model your data. In document databases, you don't really have that. There's a lot more sort of flexibility in how you design things. This is great for you once you understand it and you're really good at it. But it's challenging to know how to model things when you get started because there's so much flexibility and it's kind of open-ended. It feels a little more like art than science in some sense. So we're going to focus specifically on techniques and trade-offs and some guidelines I've come up with to help you be successful modeling your data with document databases such as MongoDB. And then we're going to start writing code for real. We're going to use a Mongo ODM object document mapper. Think of like SQL Alchemy, but for document databases, called MongoEngine. And we're going to use that to create some classes to model our data and map those classes to and from MongoDB and use that as the foundation of our application. Speaking of applications, what are we going to build in this class? Well, we're going to build an Airbnb clone, but for snakes. Okay, so we're going to build Snake BNB, and this allows you, when you're traveling with your snake, your pet snake, you don't want it to have to live out in the car or something like that. You want to get it a cage that it can live in, a proper snake cage where it'll be happy. So there'll be owners of cages who can put their cages up for rent, and snake owners, pet owners, who want to travel with their pets and have their pet have a place to stay. So we're going to create this sort of silly Airbnb knockoff clone, but we're going to model many of the operations you would see in real Airbnb on our application here. So it's going to be pretty rich in terms of data. As far as tools go, well, of course, we're going to talk about MongoDB, right? That's the database we're using. But you're also going to learn some other things that are pretty awesome in the course. We're going to talk about MongoEngine. This is the primary library we're going to use to talk to MongoDB. It's built upon another one that's very popular that is sort of the lowest level official way to talk to MongoDB called PyMongo. So you might see a little bit of both of those actually in the course. We're going to use what I think is the best tool for accessing MongoDB, something that used to be called Robo Mongo, but now it's called Robo 3T because it was acquired by a company called 3T. So this is part command line, part GUI way to interact with MongoDB, and it's beautiful and free open source. It's great. Also, we're going to use PyCharm for our Python code. You don't have to use PyCharm for this course, but you'll see me using it, and I think you'll see a lot of benefits as we go. Speaking of me, who am I anyway? Who is this voice that you're listening to? Hi, my name is Michael Kennedy. You can find me on Twitter at @mkennedy. And what makes me qualified to teach this course? Well, first of all, I host the most popular Python podcast called Talk Python to Me, and I've interviewed many people, including some of the folks from MongoDB, the company, as well as authors who've written about MongoDB design patterns and things like that. So I've had a lot of experience working with people in Python and MongoDB. I've created the Talk Python training company and written many Python courses and MongoDB courses there as well. And also, I'm part of the MongoDB Masters program. So this is a group of about 35 external community members who give advice back to MongoDB. And I've been part of this for many years. Worked closely with the folks inside MongoDB over the years. So this is what you have in store for you. Lots of awesome MongoDB and Python. I hope you're excited. Let's get right to it. Let's begin by looking at why you might choose MongoDB over other NoSQL databases, other document databases, or even other relational databases. I'm sure you've heard of MongoDB. That's why you're taking this course. But how popular is it relative to other databases? Is it really the right choice? Well, let's look at some data from 2017. If you compare MongoDB against other NoSQL databases, Cassandra, CouchDB, RavenDB, things like that, you will find one of these databases is unlike the others. Look at that. That's incredible how much more popular MongoDB is over these. And it's not just the popularity that it's 5, 10 times, maybe 50 times more popular than RavenDB. That's great. That's very important. But also the trend, right? These others are either flat or trending downwards. And this is, besides a little blip here, based on probably like the end of the year numbers or something like that, at the end of the data. This is a really big deal, right? This is incredible how much growth that is here, and it's still going up. So MongoDB is really, really popular in terms of a database that people are using. And that's great because that means it's well tested. When we get to a section a little bit later, we'll look at some of the users of MongoDB. But it's really important that there are some heavy workloads put onto these databases that you're going to depend upon. And if it can take what those people are doing, surely it can take what you have to throw at it as well. Now, MongoDB is also loved. If you look at Stack Overflow at their 2017 developer survey, and you look at the most loved databases. These are databases that the developers are using currently and how they feel about it. You see MongoDB ranks right near the top. So definitely 55% of the people who are using MongoDB love it compared to say like SQLite or Cassandra. So this is pretty good. But what's even more interesting is that it's the most wanted database. So these are technologies that you're not currently able to work with, but you would like to. So there are tons of people that want to work with MongoDB, but for whatever reason, they've got some legacy system built on, MySQL or whatever, they don't get the chance to. So all these pieces of data tell you MongoDB is a really good technology to have in your tool belt. And it's easy to get a hold of. Right? MongoDB is open source and it's free. You can just go to github.com/MongoDB/Mongo and clone it, and it's right there. So you can see it has 11,000 stars, 3,000 forks. In the screenshot I took here, it was updated 2 hours ago. It's under very, very active development. So it's a live and vibrant project. Finally, if you actually want to get MongoDB, don't go to GitHub. GitHub is cool. It's great that you have the source, but don't go there. What you really want to do is you want to go to mongodb.com/download-center, or just go to mongodb.com and click download. It'll take you here, and you download it here. You get it as a binary. So if you're on Mac, I recommend you use Homebrew to install it, but you can also download a tarball. If you're on Windows, get the MSI, and on Linux, you can actually install it with Aptitude or some package manager like that. In this course, we're not going to go into the details of setting up MongoDB, just follow the instructions. In the full MongoDB course we walk through all the steps, but we just want to get started. This is the quick start. So let's keep moving. Let's look at one of these records that gets stored in MongoDB to see how document databases work. Here we have a JSON record. This is actually from one of my courses, the Python Jumpstart by Building 10 Apps. And this is how I represent it in the database. We've got standard columnar type things. So we have an ID, we have a title, a course ID, duration in seconds, these types of things. Now, first of all, you might be wondering, wait a minute, JSON database, is that really efficient? Well, probably not. What MongoDB actually stores is a binary representation, so like a binary tokenized version of this record. But they call it BSON because it's like binary JSON. But we're humans. We don't read binary, we read text. So we're looking at the textual representation. So this is not exactly how it gets stored, but this is pretty close. So we have these regular column type pieces of information, ID and title and so on. But we also have this other thing, these lectures. Now these lectures are in this chapter represented by this record from this course. And notice the bracket in JavaScript, which basically this is, means that is a array. And the array contains a bunch of sub-objects. So this is really interesting. Instead of just having a chapter table and a lecture table and doing a join or something like that, a foreign key relationship, we're actually putting the lectures inside the same record. So this is pretty interesting. When you look at it like this, you can imagine that this is like a pre-computed join. If I do a query for the lecture, say given the ID 1001, and I get this record back, it already has the lectures. I don't have to make another round trip to the database to get them. I don't have to do a join against several tables in that original query. It's literally a primary key query against an indexed primary key and is insanely fast. And yet it already comes back with all this extra information. So this is really cool. If I get the chapter, I have the lectures, great. But you might be wondering, well, really, what if I need to ask the question in reverse? Like, fundamentally, if I need to get at lecture 10,106, will I be able to query MongoDB quickly and efficiently to get that lecture? And it turns out the answer is yes. And that's why document databases are awesome. It's not just like some nested blob stored in the original record. You can, as part of the query language and part of indexes, traverse these hierarchies in very, very rich and powerful ways. So we don't lose very much query capability just by putting the lectures in this one record. So this is really neat. And this is sort of the foundational, most important takeaway from document databases. We store them as these flexible JSON type of objects, and we can nest additional things like lists of numbers or even subdocuments as we have in this case. Now, before we move on, let's take a moment and look at who uses MongoDB. Now, programming languages and databases and technologies aren't necessarily popularity contests. Just because something's popular, it doesn't necessarily mean that it's great. Evidence PHP, for example, or VB or something like this. Technologies are popular and some of them are great, and sometimes great technologies are popular. So there are some important things that come along with being popular and used by big important companies. And that means these things are durable and tested, and they've really been through the ringer. So MongoDB has been used by some really big customers and some really interesting use cases. And I know some of the biggest ones are actually not on this page even. They're not listed here. So I'm going to take in a quick tour of a couple of customers who are using MongoDB, and we'll look at how they're using it. Okay, so the first one that I want to look at, let's scroll down here and see some names that you might know, some cool stuff here. Let's check out Royal Bank of Scotland. So banks are supposed to be conservative, right? Things like this, they probably wouldn't use weird NoSQL document databases. They're going to stick to their traditional Oracle or SQL Server or whatever. Well, if we look at Royal Bank of Scotland, they're using MongoDB to support a global enterprise data service underpinning several core trading systems. If you're a bank, the core trading system's pretty much the center of the universe, right? So the fact that they're driving that with Mongo and that's high performance and it's doing that for them, that's really awesome. Let's check out Expedia. So Expedia, they have their app built on MongoDB, and they're supporting millions of customers shopping for flights, hotels, cars, things like that. That's pretty awesome. Let's check out another one down here. EA, so video games, right? This is the world's best-selling sports game franchise, and they rely on MongoDB to scale to millions of players. That is really awesome. One more before we move on. So these guys down here a little farther at Sailthrough. Sailthrough is a company that does like outbound mail and analytics and things like that. So they are a marketing company, very much doing tons of email type of stuff, like I said, and they have over 40 terabytes of data in 120 mostly physical nodes, right? So 120 servers all running MongoDB in some giant cluster, which is a pretty awesome use case. And of course, you have things like Shutterfly running on MongoDB, Squarespace, on and on. There's a ton of cool use cases down here, but I think you've got the idea. Are you ready to model some real applications in MongoDB using documents? It's time to get our hands dirty and really start building something. So in this chapter, we're going to go through our Snake BNB application, come up with the entities, the classes and tables or collections as they're called in MongoDB, and model them out. So we're going to first look at how this modeling in document databases compares to traditional third normal form modeling in relational databases. We're going to use a pretty simple example, but I think you'll get the idea and you'll see it much more in action when we build the real app. So let's take this simple bookstore model here. We have books, they have a bunch of properties. We have people who publish those books, named publishers, they have a name, when they were founded, and you can navigate this foreign key relationship from publisher over to the publisher ID on the book. Now, we also have a user, and a user might rate a book. So we have users and we have ratings, and we have a foreign key relationship between them. And then from rating over to book, we have a one-to-many relationship there, right? A book can have many ratings. So we have a couple of foreign key relationships going on in this place. Now, let me tell you, in a real application, there'd be many more little tables with extra information like this, like ratings about books and so on. And like, let's say reviews, for example, things like that. Maybe even related items that we pre-computed from some sort of machine learning, but we want to store that in the database. So imagine this model here having like 15 tables with relationships across all the various pieces back and forth, right? So I just want to keep it simple, fits on the screen. You're not going to go crazy with it. So how would we model this in MongoDB? How will we model this using documents? Well, you would see that it's somewhat simpler. The more craziness that we had in the relational model, the sort of more contrast you will see here. So we still have our publisher and they have their ID and when they're founded. We have our user and the same columns or pieces of information there as well. Same as a book. But now our ratings, we've decided, when we get a book, most of the time we actually want to know the rating. We want to say like this is a 3.4 star book, or it has 72 ratings. Even in a list, we want to show that stuff. So we're pretty sure we want to have these ratings always with the books. So why put them in a separate table? Let's embed them. Now we still have some relationships like we had in the relational model. For example, we have our publisher ID on books, and that links over to publisher. Now, this is what in MongoDB I refer to as a soft foreign key constraint. Like there is a relationship between books and publisher. It's the publisher ID set to the ID of the publisher, but the database itself doesn't enforce this, right? So you need to be a little more careful in your app, and we'll see how we do that when we get to the code. But as I was saying about ratings, these we're not going to put in a separate collection. In fact, we're going to store those inside of our books. So we can embed these objects and arrays of either straight values like numbers or strings, or actual sub-documents like our ratings here. So we might have rating 1, 2, 3, and so on. It's actually part of the record of the book. So when we get the book record back, we already have the ratings, things like that. So again, we can think of this ratings being embedded within books as a pre-computed join. There's a slight bit of overhead if you actually wanted the book without the ratings, and you're just going to get them back and ignore them most of the time anyway, if that was the case. But if most of the time you do want the ratings, this is a huge speed up. And like I said, imagine there were 15 tables before and 5 of them could be collapsed into the books. Then you have a 5-way join going down to a single primary key query. That'd be amazing. As we discussed, modeling with documents and document databases is a little bit more art. There's a little bit more flexibility and kind of just gut feel of how you should do it. But let me give you some guidelines that will give you a clear set of considerations as you work on your data models. You'll see that the primary question for working with document databases is to embed or not to embed. That is, when there's a relationship between two things in your application, should one of those be a subdocument, should be contained within the same record as the thing it is related to, or should they be two separate collections, what MongoDB calls tables, collections, because they're not tabular, right? Should those be two separate collections that just relate to each other? So we're going to try to answer this question. I'll try to provide you some guidelines for answering this question. So the first one is the embedded data wanted 80% of the time when you have the outer or other related object? Okay, so let's go back to our example we just worked with. We had a book and the book had ratings. So to make this concrete, the question here is, do we care about having information about the ratings most of the time when we're working with books? So if our website like lists books and that listing has the number of ratings and the average rating and things like that listed as part of the listing, you pull up a book, maybe the ratings and the reviews are shown right there. Most of the time we have the book, we have the ratings involved somehow, then we would want to embed the ratings within the book, right? That's what we did in our data model. We said, yes, actually we do want the ratings most of the time. Now, let's look at this in reverse. How often do you want the embedded data without the containing document? So in the same example, how often is it the case that you would like the ratings without the book? So what use cases for maybe like where would that show up in our app? So like maybe you as a user go to your profile page on the bookstore and there you can see all the books you've rated, right? And the details about the rating. You don't actually care about necessarily the books. You just want, these are the ratings that I've given to things and here's my comments and so on. I don't actually want most of the details or maybe any of the details about the book itself. So if you're in that sort of situation, a lot of the time you might want to put that into a separate collection and not embed it. You can still do it. You can still do this query and it'll come back very quickly. There's ways to work with it, but you'll see that you have to do a query against the database and then a little bit of filtering on the application side. So it's not prohibitive. It's not that you can't get the containing document with the contained document without its container, but it's a little bit more clumsy. All right. So if this is something you frequently want to do, then maybe consider not embedding it. Now, is the embedded document a bounded set? So let's look at ratings. How many ratings might a book have? 10 ratings, 100 ratings, 1,000 ratings? Is that number going to just grow and grow the number of ratings that we have? If this was like page views and details about the browser and IP address and date and time of a page being viewed, that would not make a good candidate for embedding that, like say for views of a book, because that could just grow and grow and grow as the popularity of your site grows. And it could make the document so large that when you retrieve it from the database, actually the network traffic and the disk traffic would be a problem. I don't really see that happening with ratings. I mean, even on Amazon, like super popular books have hundreds, not millions of ratings. So this is probably okay, but if it's an unbounded set, you do not want to embed it. And is that bound small, right? Like maybe millions of views still being recorded within inside of a book would be a really bad idea. And the reason is these documents are limited to 16 megabytes. So no single record in MongoDB can be larger than 16 megabytes. And this is not a limitation of MongoDB. This is them trying to protect you from yourself. You do not want to go and just say query by, say, ISBN and try to pull back a book and actually read 100 megabytes off a disk and over the network. That would destroy the performance of your database. So having these very, very large records is a problem. So they actually set an upper bound on how large that can be. And that limit is right now, currently at the time of the recording, 16 megabytes. But you shouldn't think of 16 megabytes as like, well, if it's 10 megabytes, everything's fine. We're still got a long ways to go. No, you should try to keep these, in the kilobytes, tens, 20s, hundreds of kilobytes, not megabytes, because that's going to really hurt your database performance unless it's some situation that just makes a ton of sense to have these very large documents. So having small bounded sets means that your documents won't grow into huge monolithic things that are hard to work with. Also, how varied are your queries? So one of the things that you do with document databases is you try to structure the documents to answer the most common questions in the most well-structured way. All right. So if you're always going to say, I would like to, on my pages, show a book and its related ratings, you would absolutely put the ratings inside the book, because that means you just do a query against a book and you already have that like kind of pre-joined data. But if it's sort of a data warehouse and you're asking all kinds of questions from all different sorts of applications, then trying to understand, well, what is the right way to build my document so it matches the queries I typically do, or the ones that I need to be really quick and fast, that becomes hard because there's all these different queries and they have like, the way you model for one is actually the opposite of the way you model for the other, right? So depending how focused your application is or how many applications are using the database, you'll have a different answer to this question. So the more specific your queries are, the more likely you are to embed things and structure them exactly to match those queries. Related to that is, are you working with an integration database or an application database? We'll get to that next. So wait, what is an integration database? So if you were just working on your own personal website or some small project, you don't have an integration database. But if you work at a big enterprise, a big corporation where there's many internal systems, you may be working with an integration database. And honestly, that's not a great fit for NoSQL databases in general, but it also makes designing documents for them more difficult. So in large corporations, we have many applications that share the same data. One way that we have built applications to share data is to just share the same database. So we might have a bunch of different applications and they're all going to talk to the same database. So they all have the same concept of a user, they all have the same concept of an order, things like that. And this means the concept of the user is as complicated as it can get. Maybe the application in the top left could have a real simple user. The one in the top right actually needs something else. The bottom one is something else still. And so you've kind of got a model across all these applications, and that makes it super tricky. Also, in NoSQL databases and document databases, the relationships are enforced in the application. So that means all of these have to agree on what the constraints are, what the relationships are, and that can actually cause data integrity issues. So there's a lot of reasons that an integration database isn't a great idea for relational databases. In fact, it's not a great idea at all, but it has been used. And because there's different applications with different query patterns, it makes designing your documents more difficult. So instead, what do? We build application databases. Maybe we have a bunch of different applications just like before, but they all have their own data store and they all talk to their own databases. Of course, they need to exchange data like before, so maybe we do some sort of microservice thing where they talk to a service bus or they just talk to each other, things like that. And that means each individual green database and interaction with its own application is super, super focused and limited. And here, in these cases, MongoDB document databases make a lot more sense, and it's easier to design the documents because the range of queries is extremely focused, so you can target those particular questions against a small set of queries, the guidelines we just talked about. So this is the kind of model you want to have if you're doing data exchange within your organization and you're working with a document database. I don't know about you, but I feel like we've talked about coding and talked about MongoDB in theory enough, and it's time to write some code and use MongoDB. So that brings us to getting started with our demo application. So throughout the rest of the course, we're going to spend a significant amount of time focusing on this. And remember, we're building Snake B&B, this wonderful experience where snake owners and their pets can share other snake cages when they're traveling, so they feel totally comfortable on every vacation you need to take your snake on. Of course, it's just a knockoff of Airbnb type thing. And in this video, we're going to see how to get it from GitHub and how to get it up and running in Python and PyCharm. So we'll start out over here on github.com/MikeCKennedy/MongoDB-quickstart-course. And you can see that we've got a couple of things here. We've got some data. This is empty right now, but I'm going to fill it up with stuff as we go through the class. So you'll be able to recreate the database. There'll be instructions in there on how to restore that. And then if you go over to source, this is the most interesting part. We're going to be working in this area here, but I've made a snapshot of starter code snake BNB. And this is exactly a snapshot of what we're starting from. Okay, but I'm going to be working in here because I want to have it build up, right? Also try to do, make some branches or other save points really obvious when we get to the various videos. Right now there's no other branches, but we'll get to those. Okay, let's go and check this out. So we'll go copy what we need and we'll say git clone this, nice and quick. And let's go work with it. So over here, we have our source code and we have our snake BNB and we have our starter code snake BNB. So these are the two projects here. And what I want to do is I'm going to put this into PyCharm. On Mac OS, you can just drag and drop this onto PyCharm and it'll load the project from that folder. However, if you do this on Windows or on Linux, I think you have to go to PyCharm and say File, Open Directory. However, before I do, let's go into this folder really quick and create a virtual environment. So you may be familiar with Python and virtual environments and so on, but if you're not, let me give you the quick overview of what's going on here. If we look here, we're going to have apparently a misspelled requirements file, which we're going to take care of in a second. But notice in this requirements file, these are the external libraries, PyMongo and MongoEngine for MongoDB, and some other random stuff for working with color output on the console, as well as parsing date times entered from the user. So we need these libraries, and we don't want to install them and manage them basically as a machine-wide thing. We would install them into our virtual environment. So let's go over here and first rename requirements. And we're going to go and actually create the virtual environment, and then we'll install, we can install stuff into it. So here we are again in the source folder. So we'll say Python 3-m venv. So run the virtual environment module into .env. This naming convention, .env, something that PyCharm understands, will automatically detect and start using. We're going to pass the -copies flag. That's only required on Mac OS, I believe, but anyway, we'll go with that. Now, if we do an lsah, you can see this hidden .env, but we don't need to do anything else with it. PyCharm should take it from here. So we can go and grab this folder on Mac OS, remember, File, Open Directory on the other OSs, and drop it here. So let's go ahead and tell PyCharm about Git. The very first time, PyCharm will index the Python environment we gave it, and then it should be up and running. Okay, so let's look down here in the terminal. You should see the .env. You can ask questions like which Python, and it shows you it's the one that we created. In Windows, it's where Python, not which Python. And if we go over here, we have our requirements and so on. Now, the other thing we need to do is we need to right click and say, set this as like the relative path. So in this file, when I import some other file, it looks relative to that. So you can say, right click here and say mark directory as sources root, or just be in this folder when you run it in Python, basically your working directory. Okay, so we're almost ready to run things. The last thing we need to do is install these requirements. So we can say pip install -r, the requirements file, and that will install those libraries for us. So when we run the application, it has everything it needs. So if we try to run it now, it'll crash and say it can't find Colorama or something like that. Now, this application is empty. It doesn't do anything other than ask for a couple of prompts. There's no data access or MongoDB, anything in here. But let's go ahead and just get it to run. So we can right click on program and right click and say run program. It runs, and you can see, if I make it bigger, here we have our snake BNB, and I put a little snake there for you guys, and it asks you a question. Are you a guest or a host? Are you looking for a cage, or do you want to offer up your cage? So let's go with guest, and it lets you do things like create an account, add your snake, and so on. So I could say, I'd like to log in. So do you know, that's not implemented yet. In fact, that's what we're going to be doing next, is implementing all of these features in the database, creating an account, logging in, booking a cage, viewing cages, things like that, right? So all the actions you might do in a typical Airbnb situation. So that's it for now. We have this up and running. Let's do one more thing. Because of the output, I find this looks a little better if we just run it separate outside of PyCharm. So we can say copy the path here. And we're still in this folder with the dot environment, so we need to activate it if we're going to run it over here. So we would say dot space dot env bin / activate. On Windows, you don't need the first dot, and it's not bin, it's script or scripts. I can't remember. I think it's scripts. Either way, our prompt should change. And now we can run this. Here's our snake again. Okay, so we're all set up and ready to run our code. It's time to write some code against MongoDB and connect to MongoDB. And we're going to do that with an ODM, an Object Document Mapper. If this term's new to you, think of Object Relational Mapper like SQL Alchemy, but for document databases instead. So let's compare first this ODM style of programming against the most basic, lowest level way to program or interact with MongoDB from Python called PyMongo. So every programming language that you can talk to MongoDB from, there's many of them, 20, 30, I don't know, something like that. Many languages can talk to MongoDB, and they each have what's called a driver. And this is typically provided by MongoDB, the company itself. So PyMongo is no different. It's this low level foundational way to talk to MongoDB. And you do this in the native query syntax of MongoDB, this JavaScript JSON style of interacting with the database. Now, it's important to know that if you're working with MongoDB in terms of running and managing it, but from writing code, we're going to focus on something higher level, an ODM, so we can take structured classes and map those to and from the database. So let's see how it would work if we just use PyMongo. So we've got our app here, and we have the PyMongo package we're going to work with, and we have MongoDB, the database. So we write direct queries in this raw MongoDB API. So you have to know the API really carefully. You have to map those back to your classes. Basically what you do is you pass dictionaries to PyMongo. It uses those as part of the query, and then you get the dictionaries back. It's pretty unstructured, but it's very low level and fast. With an ODM, similarly, we've got our app and we've got PyMongo and MongoDB, but we also have another layer, the layer that we directly interact with called the ODM, Object Document Mapper. And there's a bunch of different kinds. There's MongoEngine, there's Ming, there's MongoKit, there's MongoAlchemy, Mini Mongo, and there's more than that actually. There's a ton of them. Just so happens we're going to use MongoEngine, one of the more popular and well-polished ones, I think. So in this model, we don't query in terms of raw dictionaries against PyMongo. We just talk to the classes defined by the ODM. And our queries are based on those types, on those classes. That itself will translate to the MongoDB API, sometimes in real basic ways, sometimes really advanced ways. And it will actually leverage some of the advanced operators, the dollar operators, if you're familiar with them from MongoDB, like $set, $add to set, things like this. So really cool that it leverages the advanced operators, not just, save this document, read this document type of programming. I think the ODM model is a much better way to write your application. You'll see there's not much structure in a schemaless database. So having a little bit of extra structure defined by these classes that are part of this ODM model really adds a lot of safety to your application, in my opinion. The ODM we're going to use for this course is MongoEngine. And you can find its homepage and details about it, documentation and so on at MongoEngine.org. So MongoEngine is open source like many things you'll find in Python. As we said, it depends upon PyMongo. You saw us install it earlier. We just did pip install MongoEngine, and that installed PyMongo along with it. We did that through the requirements file, but you can do that directly if you prefer. You can find MongoEngine on GitHub. You can see that it's quite popular, almost 2,000 stars. This is much more popular than the other MongoDB ODMs. As far as I can tell, looking at the other ones, this is definitely the most popular, or at least among the most popular of them. And it's very actively under development. I just took the screenshot right now before I started recording here to give you the latest version. You can see that it's been updated in the last 24 hours. Some other stuff under the actual code has been updated in the last 21 hours. So very active. This is important for an open source project you're going to depend upon. So I think, judging by that, MongoEngine is the best choice. And the API is excellent. We're going to start working with it next. The first thing we need to do to start working with MongoEngine is tell MongoEngine how to speak to MongoDB. Let's go back to our Snake BNB app we've been working on. And we're going to go in here to this data section, and we're going to create a new Python file called Mongo Setup. So in here, we're going to write a simple method that we can call from other places. And as you'll see in the slides that we look at later, for real applications that use proper connections, encryption, accounts, things like that, this can be a little more complicated, but it's going to start out pretty simple. So we'll say global init. And in here, we just want to call one function. So we're going to have MongoEngine here. So we're going to import MongoEngine, and we just say MongoEngine.register connection. And the first thing that we pass is an alias. So I'll be real explicit and say alias equals core. Now, what is this alias thing about? We can have multiple connections to even multiple databases or even multiple database servers registered here. So we could have like a core data and say analytics for just analytics that goes to a separate database that maybe has tons more data because it's like page views and actions and so on. But we might keep that separate so we can back it up on a separate schedule, something like that. And then we need to set the name of the database, and we'll set that to Snake B&B. Do a quick format here, and it's all good to go. Like I said, this gets more interesting in real connections, but we're going to need to call this to talk to MongoDB. So let's go over to our little program, and you saw up here at the top there was this to do set up MongoEngine global values, and that was basically what we were doing there. So we need to come over here and say we need to go to data.mongo setup as we'll just call it Mongo setup, and this should be pretty simple, Mongo setup dot global init. Now we just need to make sure we call this once in our application, and we need to do this before we actually interact with anything else. So let's go and apply these settings over to our entities as well. So we'll look at snakes first. Now, this model is going to be mapped into one or more of those databases. Well, one among many potential databases. So the way that we can tell it how to work, MongoEngine will use a property we can add to it. We can say meta equals, and we give it a dictionary, and we can say db underscore alias, and we'll say core here, okay? While we're at it, let's say collection is snakes. So even though we called it capital S snake, the thing in the database where these records, these documents are stored will be called snakes plural lowercase. And here we can tell it this goes into the core database, unlike maybe the analytics one or something like that, right? We're only going to have one in here, but for our example, you want to have this here. So in case you want to add more later, right? I'll go ahead and add the rest of these to owners and cages, but not bookings, because bookings is going to be nested inside here. All right, so we don't need to tell that how it gets stored because it's stored alongside cage, which we'll say cages, and no surprise, owners. All right, so those are our three top-level entities that map to our three top-level collections in MongoDB. Now we've registered the connection by using our Mongo setup global, which we just call register connection. Like I said, this can get way more complicated in reality. And then we just go and we set this meta to use the core connection as well as naming the actual table or collection it's going to go to. Let's take a moment and look at this concept of registering connections. We're going to need to work with MongoEngine, so of course import MongoEngine, and we need to set the alias and the name of the database. So just say MongoEngine.register connection, give it the alias, give it the name. We need to call this before we start interacting with our classes and other types. Before we try to do any queries or save any data, this has to be all set up. So this is what we wrote in our application, and this works fine when you're talking to the local MongoDB running no encryption, no accounts, default port, running on the local machine, same machine as this code. Now, if you're doing this in production, there's more to it, right? You need to set the username and password, which you have to set up in MongoDB. There's none by default, so you got to set that up with the right permissions. Probably it's a different server on an alternative port, so set the host and the port. You would like to create some sort of admin account, which is associated with that username and password. So you say, look, you authenticate an admin, use this mechanism. And finally, if you're going to do connections across, somewhere outside your data center, you pretty much should just turn this on, is you need to turn on SSL and configure the server for SSL. And then you pass that additional data in addition to the alias and the DB. Now, there's a lot going on here, and deployment and running MongoDB in production is not as simple maybe as it could be. Certainly, it's something you need to be very careful about, like no authentication, no encryption. Right? Don't run your code that way. It's fine to do it for development, but don't do it for production. In my full MongoDB course, I actually go into spend an hour, go and create a Linux server and set it up in a cluster of the database and the web servers and those kinds of things, and really make this work perfectly and safely. But in this course, we're not going to go into it. I just want to leave you with, you need to set this up. You can look at the MongoDB.org site as well, or MongoDB.com site, and go through the documentation on some of the steps, or just take my other course if you're really going to go and use this in production. So far, we've modeled our data with Python classes, but there was no real MongoEngine entity stuff. They wouldn't actually be saved or processed by MongoEngine. It just happens to be we kind of sketched them out in Python class style. So we're going to change that now. We're going to go make our standard plain old Python classes proper MongoEngine entities. Snake is pretty simple, so let's start there. So in order to work with MongoEngine over here, I'm going to have to import it. Now, you might want to do from MongoEngine import some things, but I like to be real explicit. Like these things are coming from MongoEngine, even in my production code. So this is how I'm going to do it. And we're going to set the registered date to a particular type of descriptor that comes from MongoEngine. And at sort of the type level, this tells MongoEngine what type of data and constraints and requirements go onto this field. However, at runtime, it's going to act like, say, a datetime or whatever it is. In this case, a datetime and species would be string and so on. So we'll come over and say MongoEngine.datetime field. And we'll just go like this. So this will tell MongoEngine to map that to the database as a datetime field. Over here, we'll say MongoEngine.string field. And over here, the length, let's say this is in meters, and that's probably decent to have floats. Right, so this will be a float field. The name, again, a string field. Whether it's venomous or not, that's true or false. I guess it could be a number like level of venomous. I don't know. But we're going to call this a Boolean field. And that's that. So our snake is all ready to map into MongoDB. MongoDB doesn't have things like required fields or default values or anything like that, but MongoEngine does. So let's change this to make it a little simpler to create a snake. So for example, registered date is almost always just whenever you inserted it, right? So what we can do is we can come over here and set a default function that will execute anytime MongoEngine inserts a new snake. So we're going to start with datetime. And so the function that we want to call is the now function, which gives us a full year, month, day, hour, minute, second representation of time. So we'll come down here and say datetime.datetime.now, and be very careful not to put the parentheses. You're passing the function, not the value of now. That would be like when the program started. So that can be a little tricky. Over here for species, let's say that you have to say the species. So we can say this is going to be required is true. In fact, the length is required. The name is required, whether it's venomous is required. We could have in things like minimum values have to be like 0.001 or, things like this, right? So you can't have like a negative length. There's a lot of cool constraints that we can do with our types here. So this snake is now ready to be used in our database. Let's look at the next one. Let's work on the cage next. So again, import MongoEngine. We'll use that in a few places. This is exactly the same here. So set the default. And then the name is just going to be a string and so on. So I'll just sketch these out for you. So these seem like reasonable types here. And let's go ahead and set the required properties for things that we require. So most of these will be required. And whether or not we allow dangerous snakes, if you don't set that, let's say, no, by default, you're not going to have a dangerous snake. Okay, so these are just like the snake before. This, however, gets more interesting. So we're going to come down here and we're going to set this to be a MongoEngine.embedded document. So we could have just a single thing like a booking or like say embed the snake in the owner or something like that. But we want to have a list of embedded documents. And then what we need to pass in here is the actual type that is contained in there. So we're going to import data.bookings.booking. One other thing that I also realized I forgot to do in the previous one, so we'll go back and fix that, is we need to tell MongoEngine that this is a top level document. So we need to make this have a base class of type document. We'll do that for snakes as well. Now, let's go to the booking. We were just working with that. So this one, recall, is the type that's embedded within the cage. It's embedded in the cage. That means it's not a document, right? That would be a top level thing. This is an embedded document, right? So this can be contained within other documents, but it itself cannot be top level. So let's go ahead and set these as well. Now, when we're talking about IDs in MongoDB, the default is something called an object ID, like a UUID or GUID or something. And so when we're talking about a reference, typically it's one of these. It doesn't have to be, but it typically is. There we go. So we've got our two references as object IDs. We've got our booking date, which does not have to be required and doesn't have a default value. This is when it was booked, which happens after the booking slot was made available. But at the time of creation of the slot of booking, right, with like putting up for booking, you have to say the check-in and check-out date. And again, the reviews, these are not getting set until after. I set this to 0 so we can say like, require it to be 1 to 5 if they actually rate the thing. And then you can sort of exclude the ones that are 0. The final one is owner, and it's very, very similar. I'll just sketch that out for you. Okay, so we've got our flat pieces here, our registered date, name, and email, and now we're going to have a list of IDs. So we'll come in here and say MongoEngine.list field for both of them. So this will let us store the object IDs that refer to the snakes and the object IDs that refer to the cages. Last thing to do is make the base class the document here. All right, so what have we done? We've set all the fields to their respective types out of MongoEngine as descriptors. We've set either default or required values. And we've set the metadata, which talks about which database connection to use and what to call the collection when it goes into the database. And we've done that for our 3 top-level items here. The one that is different, that stands out, is the booking, which is embedded within the cage. And this is an embedded document, but otherwise, everything goes pretty much the same. Let's review the core concepts around creating MongoEngine entities. We started out by creating what I called basic classes. These are classes that could just as easily been mapped to a relational database because they just have flat fields or columns, if you want to think of them that way, and none of the nested or particular capabilities of document databases. So the one that matched that was the snake. And the snake, we make sure that it derives from MongoEngine.document, and then we specify the fields by passing along or creating these MongoEngine descriptors. So we said there's a registered date, and that's a MongoEngine.datetime field. The length, that was a float. That was the length of the snake in meters. The name of the snake is a string, species as a string as well, and whether or not it's venomous, that's a Boolean, true or false. So you can see we can map out the types for this basic snake class really easily here. Of course, our snake should have default values, constraints like required fields, and things like that. So here we've taken that same snake class and we've added a default value for the registered date. We said, just call the function datetime.datetime.now anytime you insert a new snake. So it's going to automatically tag that new entity or that new document with the date in which it was inserted. Now remember, be super careful to not call the function now, but pass the function now. Okay, we also set the length to a float. We said that's a required float. You have to specify the length or it'll MongoEngine will give you an error, so you can't insert this thing. That field is required. It's interesting that that's not a feature of MongoDB. That's a feature of MongoEngine. So by using MongoEngine instead of, say, PyMongo, we get these additional features. Same for the default. And name, species, and venomous, also these are all required, so we can do this here. Now, again, this is still one of these sort of basic classes with just our constraints and defaults. Let's look at the cage. The cage is more, takes better advantage of the document database. So we have the name, the price, the square meters, required standard stuff there. But we also have the bookings. These are either the times in which a cage could be booked or an active booking where a snake has registered to be there on a certain time. And we model that through the booking class. And we said this cage is going to embed the bookings into it. So to do that, we use the MongoEngine embedded document list field. So a list of embedded documents. And the argument we pass is the type of embedded document. So it's a booking that we're putting into this list. All right, now, how does this look if we populate this cage and we add a couple of bookings and we call save? Well, it looks like this. It has the standard fields, right? Like a auto-generated _ID, the date that was registered. This is set as the default value in the full class. We have the name, the price, the square meters, and so on. So that's all standard stuff, and we've seen that before. But the bookings part, check that out. So we have bookings, and it's a list, right? Square brackets, technically an array in JavaScript, right? And the items in this list are those bookings. So we have a check-in date, checkout date, and the ratings. So we have added 2 bookings in here. Now we didn't fill out they're not booked, so we don't have a guest snake and an owner ID, and they haven't already taken them, so they haven't rated it or given it a review. So some of the pieces are not saved into the database to save space. Nonetheless, here we have our embedded bookings inside of our document, and we did that through the embedded document list field. We have our models, our classes in place. We have MongoEngine registered and told to connect to the default values for all the local stuff for MongoDB running locally. I already have MongoDB started up and running. Check out the documentation on how to get that working on your operating system, like I said at the beginning. And it's time to create an account, log in, basically start implementing all these actions. And now we'll really get to start programming with the entities we've designed in MongoEngine. So let's begin by going down here to create account in program host. And we're going to be able to use this for actually both the host and the guests. All right, so you can see there's a couple things we have to do, and then we're going to create the account. So let's work on this get name and email first. So we'll say name equals, and we'll just use simple input stuff. What is your name? Something like this. And we'll do email. We should, of course, have them, give us a password and things like that. But this is not a real website. We're not really actually logging in. It's just sort of a user creation type of thing. So we're going to create the account. Now, I could go write the MongoEngine code to talk to Mongo and do the inserts here. But you'll see that we can do much, much better if we isolate all of these behaviors within a central location that we can use throughout our application. In these NoSQL databases, these document databases, there's not much structure in the database. So we already have some structure added by having our classes, our MongoEngine types that we work with, but we can also do a little bit better by having like a centralized data access piece. So that's what we're going to work with here. Let's go create something called a data service, and we'll just put a bunch of functions that we need to work with here. So let's go back and let's import this, and I'm going to import it in like a little short way. So we'll say import services.data service as SVC. Okay, so we're just going to use the functions out of that module by calling it that. So if we come back down here, instead of saying not implemented, let's say this. Say svc.create an account, and we're going to pass the name and the email. What we're going to get back is an account. So we want to actually store that in the statefulness of our application. Again, in a web app, this would be with cookies, and we get it back from the database every time. But we have this state thing which has an active account. So what we're going to do is we're going to come over here and we're going to say state.activeAccount equals this. So we're going to get back an account from here. Now, PyCharm says, whoa, there's something going on here. There's no account, or there's no method called create account, no function. But if I hit Alt-Enter, then it'll say, you want to create one? Of course, we want to create one. So name, let's even give this a little bit of type hints here. Say it's going to return an owner. Okay, so that's all well and good. Now we need to use this. So now we get to programming with MongoEngine. How do we create one of these owners? Well, how would you do it if it was a regular class? You would say this. And you would set some properties like name equals name, owner, email is that. And now we want to put it in the database. So we do that by using what's called the active record design pattern. We'll just call save right on this. Now we want to return owner. Now the important point here is when we call save, all the default values are set. When we call save, the primary key, the underscore ID, is automatically generated. Here it's just .id at MongoEngine, but in the database level it's underscore ID. That's automatically set. So this thing is up and running. We should have everything working well here. So let's go ahead and try to run this and see if everything's hanging together. Oh, let me run it over like this. So here's our snake BNB. We're going to go and say we're a host. Notice at the prompt here, this little yellow thing, there's no name. So we'll go and create an account. This is with my name. My name is Michael, and my email is michael@talkpython.fm. Boom, logged in. You can see now the prompt has my logged in name. The next thing we got to do, let's just go from top to bottom. Let's go and log in. However, there is a problem. What if I say I want to create an account, and I say my name is Michael2, and I say it's michael@talkpython.fm. If I hit enter, there's just two of those. That's bad. So what we want to do is we want to do a little check over here. So this is great. We got this working. And let's go ahead and annotate the type here as well. Let's say this is an owner. That's going to let us, when we interact with it later, say things like this and get, all the IntelliSense and whatnot, snake IDs and whatever. Okay, now before we do this, we want to verify that the account doesn't exist. So we'll say old account. So let's say find an account by email. And again, this doesn't exist, so we'll create this function over here. This will let us see how to query. All right, so to insert, we create one of these and we call save. To do the query, we're going to do like this. We'll say owner equals, we work with the type, and we say objects. Now, there's a couple of things we could do. We could say filter, kind of lose autocomplete here, but that's fine. We could say filter, and we could say email equals email. Okay, so we would match one of the fields there. All right, and we would not put that, of course. And this is going to return a query, and we want just one of them, so we'll say first. Now, it turns out when you have just one filter statement, you can actually condense it down like this. So we'll go ahead and write that. And we'll just say return owner. Okay, so there's our find account by email. And we'll check. If old account, it'll be none if it's not found. So if there's an old account, we'll print, I wrote a few functions, error message, success message with some coloration. We'll say error, account with email already exists. And let's make this a cool Python 3.6 f string. Like so. Of course, we want to bail. We don't want to actually create it. And here we could maybe do something like that. Print, let's do the success. Created new account with ID. And let's say state.activeaccount.id. Like so. Great, let's just run this one more time. So we're going to come in as a host. We'll create an account. Let's call this, call it Sarah. So Sarah wants to come in. Maybe she's going to be able to, she's going to be a guest. But right, we're going to use this host path to do it for a second there. So Sarah at talkpython.fm. Great, we've created a new account. Now let's just test this thing again. So we'll say I want to create an account again. Sarah, doesn't actually matter. Let's say Susie, and it's Sarah at talkpython.fm. This should no longer work. It should go and query the database and find this. And no error. An account with email Sarah at talkpython already exists. Perfect. I think the create account is done. So we saved some data, and it looked like it went into the database, right? When we successfully saved it, we saw an ID was generated. When we tried to log in with the same, or create an account with the same email, we got an error. No, that already exists. So it's definitely working. But let's look at the data with my favorite tool for working with MongoDB, Robo 3D. It used to be called RoboMongo, Robo 3T. So here it is, and you can see just by virtue of calling save that actually connected to the database, created this particular, connected to the server, created this database and the various collections. We only called save on owners, so we only have owners so far. Never mind the fact that we've created the other types. We haven't saved anything there, so it doesn't exist. And we can come down here and we can say view documents, and we actually have the two documents here. Remember, we created two accounts, and we can view them this way. And there you go. We have Michael and my email, Sarah and her email, the registered dates and times, and we don't yet have a snake or a cage because, well, we haven't implemented the ability to do that. But we're going to have snake ID and cage IDs in here as we create these snakes and cages. This is a really great way to work with the data. If you go back to this mode, you can even edit it and make changes in here if you really wanted to. All right, so definitely recommend installing this. It works on all the platforms. It's free and it's awesome. We're able to create our account. So let's now add the ability to log in once we exit the application. So we're over here in the log into account and the program host. This is super easy. We just have to get the email from the user like this. So we'll say something to the effect of, so we're going to log in, ask them what their email is, and let's go ahead and do a strip and a .lower on this. And in fact, let's always store that. So I'll go back up to our create account and do that here. So strip takes all the white space in case there's like a space or something on the end, and lower, of course, makes it lowercase. So then we just need to see if the account exists. Well, we actually already wrote that. So let's say this. Say the account is the service.find account by, guessed it, email. And then we'll say, we add a little error handling, say if non-account, say error message. So nothing there. And if it worked, all we have to do is save it and maybe say, you've logged in, yay. So let's say state.activeaccount is account. And then we'll do a success message. Logged in successfully. and then our little prompt will change straight away. So that should be good. Let's try this. Come over here to the host. Let's try to log in. And remember, there's no real passwords. We're just sort of playing around with accounts here. So Michael at talkpython.fm. Boom, logged in successfully. Awesome. And you can see the prompt changed. Let's try to log in again. I'll try to just use Jeff at j.com. Nope, could not find email with Jeff at j.com. Looks like login is working. Next thing we need to do as the host is to be able to register our cage so then people can view it and maybe book it. That'd be great, right? So let's go over here and work with that. Now, the cage has to be associated with an owner through this soft foreign key relationship in MongoDB. So we're going to require an account, and that's going to look like just an error message. So like something like this. So we'll just say, if there's no account, you must log in first to register a cage. All right, so now we know we have the account. We're going to use that as part of it. And let's go ahead and figure out how many square meters this is going to be. So we'll say meters equals something like this. Now you might want to just directly convert that into a float, but I found as I was interacting with this application, like I'd accidentally like go to register a cage and I meant to list them. You want some kind of way to cancel out. So let's just suppose if they don't enter anything, they just hit enter, it kind of short circuits everything. So we'll say if not, something like this. So if they don't enter anything, we'll just bail out. So otherwise, we'll just say float of meter. So convert it from a string to a float. We're not doing error handling in this, right? You guys should probably add that, but we're going to just do this. And we have to ask a bunch of other questions. Is it carpeted? Does it have toys? Things like that. And let me just copy that over. There's no point in seeing this typed in. It's just user input stuff, right? And then we want to go down and we want to actually register the cage. Again, we want to do this at our data layer, not here in our application code. So we'll say svc register cage. And again, that doesn't exist, but it's going to in a second. So we are going to pass the account. We'll pass the active account here. We'll pass the name of the cage. We'll pass whether or not it allows dangerous. Just all of these items. Whether or not it has toys. Whether it's carpeted. And the meters. Okay, so we're going to go and call this function, which obviously doesn't exist yet, but PyCharm will write it for us. Thank you, PyCharm. So here we can say this is an owner. Here's the name and string and so on. There we go. And let's say this is going to return a cage, which we have to import at the top. Again, thank you, PyCharm. So this is very, very similar to the create account. We're just going to create a cage and save it. So we set all the properties and we'll call cage.save, and that's going to store it in the database. Now we want to remember, if we look over at our owners, it has cage IDs to manage the relationship. So the order in which we do this is super important. Now we need to be a little bit careful with this account here. We want to make sure that we're getting the latest account from the database. So we'll do something like this. We'll say account equals find account by email, this active account dot email. So that makes sure that we don't have any stale data. Then we're going to go account dot cage IDs. This is a list, so we can append to the cage.id. Now it's super important, the order here. We must call save so that this is an actual generated value. It's just none beforehand. So we want to make sure that's generated in the database, and then we can return the cage. So that little warning up there goes away because we are returning the cage. The other thing that we need to do is this has changed the account, but we haven't pushed those changes back to the database. All right, so our register cage seems like it's working. Let's go over here and let's do one more thing. This active account needs to have that data adjusted as well. So let's go over here to state, and has a reload account. That's not written yet. Let's do that. So this is super easy to do. All we have to do is go to the database and pull it back. So we have this active account global variable, And we can come over here and say import the service. And here we can just say find account by email, active account.email. All right, that's all we got to do to reload it. So this will make sure that when we work with our state.activeAccount, it's the fresh one that just got its data changed down here. Let's do one more thing before we carry on. Let's go ahead and implement register cage here, and let's spell suppress correctly. Let's add the ability to list our cages so that we can test that this actually worked. Let's also do a success message. Registered new cage with ID. Make that an F string, actually cage.id. So we got to store that up here. Excellent. So now we've got our cage and we'll see that come out. But let's go ahead and we're going to require an account again, which is the same info up here. And all we got to do is get the cages. So let's write something like this. We'll say cages equals service.find cages for user. All right, got to write that function. There we go. Creates an account. Let's not call it active account. We'll just say account. And that is an owner. And it returns a cage. Actually, not a cage. What does it return? It returns a list of cages. So we got to go to the typing module. Here, typing, and do cage. Okay, perfect. So what we're going to do is we already have the owner, and because of our refresh account stuff, it should be fresh. So we'll have cage IDs, and we have this account.cage IDs right there we can use. So now how do we query for this particular thing? We're going to do something we haven't seen yet. So we're going to come to the cage, and again, we're going to go to this objects. I'm going to do the query. But instead of saying, remember before we had email equals, and that did the query against MongoDB for testing equality, we have something different we need to do. We want to go to the ID of the cage, and we don't want to just say, well, it's equal to, it's not going to be equal to the list, right? We can't say .cage IDs because one is like an object ID and one is a list of object IDs. So we have to use a special operator. And MongoDB has all these so-called dollar operators, $set, $in, $not, $or, these types of things. And the way we work with those in MongoEngine is we use a double underscore to say we're applying this to the ID, but then there's this other thing that we're doing. I'm going to say in. So this query right here, let me do a little cleanup. This query says, go to the cage and find all the cages whose ID is in this list of IDs, right? And now we'll have cages equals, this is a query, but we want to execute the query and sort of snapshot it for our app. So we'll return cages, and that should make our app totally happy. That little warning went away. Okay, great. So we've written this function and we've used the in operator, the double underscore, to access it. Here's our cages. We just need to print them out. For C in cages. And let's make these F strings, and we'll come here and we'll say C dot. What do we want here? We want name. Let's also print out something like this. You have however many length of cages you have, and then we'll print those off. Okay, let's try to test these two things that we've written. For host, we first want to register a cage. Actually, let's try to list our cages. Log in, Michael at talkpython.fm. And let's list our cages. You have 0 cages. Great. So let's register a cage. Now we're logged in. It'll let us. It's 2.2 square meters. Yes, it's carpeted. Yes, it has toys. No, it has no venomous. This will be Bully's cage. It looks like we haven't set the price. We've forgotten something, haven't we? Okay. So good thing we tested that here. Say price, and this will be, how much are you charging? All right, let's go add price here. Price. Cage.price. Okay. It was kind of annoying that crashed, but it's also cool. Why is that cool? Because, hey, we said the cage must have a price, and it didn't. If that was regular MongoDB, that would have just let that happen. But because it was MongoEngine, it did not. All right, let's do this again. list my cages. Whoops, list my cages. We have no cages. Let's register a cage. Do this again. How much are we charging? We're charging $29 a night. This is one fancy cage, folks. Boom, we've registered a new cage. Now, let's list your cages. Ooh, we have one cages. Maybe a plurality thing there, but pull these cages out. Let's register one more cage. This is a huge cage. It's carpeted, it has all the toys, and this one's even for venomous snakes. This will be the large boa cage. Who knows? And this is 30, 39. Now, if we look at our cages, we have 2 cages. Beautiful. So it looks like our registering and our listing cages is working great. Let's add a bookable time to one of our existing cages. We were able to register cages and list them. Now let's make them available for snakes to stay in. So we're going to work on this update availability method here. We've got our requirement that you have to have an account because they're your cages, whose cages you're going to manage, right? Things like that. And we're going to just print out the list cages. I've changed that slightly so it has a number. I'll show you really quick. I'm using enumerate and an index. So it says 1, 2, 3 instead of star, 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 because we want to ask like, hey, what cage do you want to work with? So we're going to add that here. And just for the sake of time, I'm just going to paste that. So it's going to say, what cage do you want? Either you can cancel or it's going to parse that into an integer. And then we're going to work with a particular cage. So let's go down here and say selected cage. Oh, first we need the cages. Let's say cages equals, we'll just use our service again. Get the cages for state.activeAccount. And we'll go down here and say cages of cage number -1. Because we're showing it to them 1, 2, 3. We got to convert that back to 0 based. Okay, once we've got our cage set, we need to get the dates. We've selected this cage. We'll say the name that you're going to work with. And then we're going to say enter a date, year, month, day that you'd like to start this available time slot on and for how many days, right? So I want to start on a particular date and make it available for 5 days. Now, we're using this thing called parser. And that comes from dateutils. So Python-dateutils, the module name, it's in the requirements already. Parser is a really sweet way to parse date times. It has many, many different formats it understands. So we're going to use that instead of the built-in date time parsing. Now, once we have this, we just need to go and use our service and write another data access method. So we'll say add available date. And what are we going to pass? We have to have the account. Let's say active account there. Of the selected cage that we're going to add it to. We have to have the start date and the days. And let's go ahead and say state.reload account because this might change the account. And then we want to just have a little success message like, hey, good job. And f-string this. Okay, so now we're down to just pure data access in Mongo. The interesting part, right? Let's go have PyCharm add that function. And we'll have a few things here. So this is going to be an owner, cage, a date time, and an int, and it's going to return nothing. Okay, this looks great. So remember, what we're adding here is actually a booking. And bookings are not top level items, but we'll go and create one to get started. And we'll say booking is a booking like so. And we just got to set the properties. This one, we got to do a tiny bit of math here. So we'll say start date plus time delta. Now we want to change the cage. And the way it's working probably is fine to just change the cage and call save, but I want to make sure that we absolutely are working with what's in the database. So I'll say cage equals, actually, we can just look it up here, I think. I'm not sure if we need it again. So we'll just say cage.objects id equals cage.id dot first. Okay, then we're going to go over here. Selected cage that was. Let's change that here. Again, remember, the bookings are not top-level items. They live inside of the cages. So here we're going to append the booking here, and we call save on the cage, not on the booking object, right? Because it doesn't live its own. It lives inside the cages. Here we could return the cage, I suppose, if we want, because here's kind of the updated cage. We could even tell consumers that happens. I guess we don't need our active account here, do we? So we can go ahead and drop that. And let's just do a quick cleanup here. Get rid of this. We're not doing that. Nothing changes there. Okay, great. It looks like we can probably add some time. Let's go ahead and try to test this out here. We're going to be a host. We need to log in. Let's see our cages. Okay, so we've got these two. Let's update the cage availability. The large boa constrictor one is available, so that's going to be number 2. Great, we've selected it. It's going to be 2018/01/01. Brand new year, cage is available. And let's say that's for 5 days. Great, a date was added. Let's add one more. Cool, now if we list our cages, you can see our large boa constrictor cage now has 2 available bookings. It has this time for 5 days and that time for 10 days, and neither of them are booked because no guests have come along and actually booked it. But it's available, and now they can go and ask, hey, what cages are available for my snake? And when they ask, this boa cage, this large boa cage, should come up. Maybe we'll make a little side money while our boa constrictor is not using it. So before we finish the host side, where you actually can see your bookings and things like that, that turns out to be one of the most complex types of queries we're doing in this entire application. I want to make sure that you can book some stuff so you can see it, so the data comes out when we write it. That'll make a lot more sense. So let's take a moment and focus on the guests side of the things. Let people come in, log in, create an account, register their snakes, and so on. So if we go up to the top to our little switch action thing here, notice that I'm using the create and login from hosts. There's no reason to write that code twice. We'll just use that one. Now, the thing I want to focus on for a moment is adding a snake and viewing your snake. Now, this is super, super similar to what we already did. So let's go ahead and just talk through this real quick instead of write it from scratch. So just like before, we have to have an account. We ask a few basic questions like, what is your snake's name? Let them cancel by hitting nothing in the first one. Get the information about the snake, and then we call the function add snake. And you can see this is very, very similar. So we're going to get the owner back, and maybe it makes more sense because we've been writing the others like this to go like this. We're going to create the snake and save it. But remember, the relationship between snake and owners is managed by the snake IDs inside of the owner. So we're going to go get a fresh copy of the owner from the database, update that, and save it. And then we'll give back the snake that we just created. Also, we call a quick reload account to make sure the snake IDs, for some reason, if they get reused real quick, are in the active in-memory account. So that's all it means to create a snake, just like creating a cage was. So everything is exactly the same there. And then to view your snakes, we just write the function, get me the snakes for the user, and then we loop over them. That, again, is very much like the cages. We get the owner, in this case, just to be sure that we have the fresh set of IDs there. And then we do the ID in owner.snakeIDs, and we can call the all function and then convert it to a list. I suppose we could probably skip this, but either way, this is all good. So this gives us our snakes, and we're going to list it out. Let's go ahead and just run that to make sure this is all working here. This time, we're going to be a guest. And let's go ahead and log in. And this time, I want to log in as Sarah. So Sarah is going to be my guest, and Michael is going to be the person with the cages. So log in. So we're logged in as Sarah. And let's say I'd like to view my snakes. You have 0 snakes. Okay, let's add a snake. Then I have Slither, and Slither is 1.2 meters long. This is a large gardener. And no, those are not venomous. So we've created Slither, and let's add one more snake. This is going to be Bully, and Bully is 0.4 meters. Let's say this is a bull snake. No. Now, if we say view your snakes, there's your 2 snakes. Okay, so our guest side of registering a snake so that we can book it into a cage and viewing it, that kind of stuff, is all finished. So we have cages, we have available dates in cages, and we have snakes. It's time to book a snake into a cage in one of those available dates. This turns out to be one of the more complicated things we're going to do in this application. And there's a lot of like input and juggling stuff. So I'm going to paste a few things here just about asking questions about the dates and stuff. And then we're going to go and write the database queries from scratch. So let's start here. We're going to start by making sure you have an account. And then we're going to get all the snakes and make sure you have a snake, because having an account is not enough. You also have to have a snake you can put into there. We're going to ask some questions about when do you want to do this? We're going to use Python date util to parse that. So just like before, we're going to do a little error handling to make sure like you're not trying to book some sort of reverse thing like I check in before I check out. I check out before I check in. Something like this, right? Okay, so then the next thing we need to do is find out the available cages. And this is where it gets interesting. So we're going to write a function called getAvailableCages. We're going to take the check-in, the checkout, and the snake. Oh, we also need to figure out which snake you want. So first of all, let's do a enumerate, list out your snakes, and we'll say snake 1, the snake 2 is that, and you'll pick the snake. Okay. So take our snakes, pick that, got our time, and then we're going to go to the database and find a particular cage that we can work with. Now, that's not all there is to it. So this is just going to get us the cages that could be booked, and then we have to ask, right, that's this little section right here, then we have to let the user pick a cage, and we'll find the underlying booking behind it. So let's write this function. So this can be a datetime, and a snake. You, of course, don't have to put the type hints, but I find like at the data access layer, it's really helpful. Maybe through, you can see through the rest of the application, I'm not doing this, but at the data access layer, I find it really helpful to say, like, these are the things that go in, these are the things that go out. This is like how we're working with the database. Okay, so here's where we get down to business. We're going to come down here. Let me move this up for you. So we need to do a couple of things. We need to find all the cages that have bookings that are not booked between this time and that time. All right. And we need the snake information because not all cages allow poisonous snakes, and they don't all necessarily fit. If I have a 20-foot snake, I can't put it into a 2-foot cage. So let's just do a little quick rule of thumb to say, if your snake is 4 times longer or more than the cage, then the snake can't go into it, right? Snakes can curl up, but they can only curl up so much. So we'll say something like the minimum size of the cage we're going to get is snake.length over 4. Okay, so this is going to be part of our query. The date's going to be part of the query, and whether or not it's venomous or not. So we're going to do a few interesting things here. This is definitely one of the more complicated queries. So I'm going to go to the cage, and we'll say objects. And when you have these complex queries, I find it's nice to spread this across multiple lines. So I'll say .filter. I have multiple filters, and these are effectively ands. So I'll say square meters. Now I'd like to say, let's say equals min size or greater, right? Just like we saw with the dollar operators about in, there's one for greater than or equal, and we can say the square meters are greater than or equal to this minimum size. But that's not the only thing that we need. We also need to go and do another pretty wild thing. We want to go to the bookings. Now remember, just to refresh, over here we have a cage. The cage has a bookings field. We go to the definition for bookings. Bookings have a check-in date and a check-out date. We want to work with that. How do we do that in MongoEngine? We come over here and we can traverse that hierarchy with underscores as well. So we can say bookings.check-in date. And we want to have the check-in date before or equal to the check-in that was passed, right? So the time you can check in has to precede the time this person is checking in. And then we'll do something similar for check out. Okay, so this is part of the query. Now, if the snake is poisonous, we also want to say that they allow poisonous snakes. So we'll say this. We'll say if snake.is venomous, we need to augment this query. So we can do that because it hasn't executed yet. It's like the potential to be executed. So we can say query equals query.filter. And what is the thing? Allow dangerous snakes. That's what we want to work with. Equals true. Because non-dangerous ones can stay in cages that will either allow or not allow dangerous snakes. But if it's venomous, we have to have this additional criteria. And maybe we want to have some kind of order by, like we'd like to show them the cheaper ones. So let's go like this. We'll say cages equals, and we'll finalize the query like this. We'll say query order by. Now, you don't do this sort of default, this named parameter type thing for this. So we're going to order by price. And the default is ascending. So cheapest ones first. And maybe you want to see the biggest ones first as well. So we'll say square meters like this. So we're going to say first order by price, lowest to highest, and then show us if like the price is the same, show us the largest ones at that price level down to the smallest ones. Excellent. So this is pretty much working. It turns out, it looks like it's going to completely work, but it turns out that there's a challenge we're going to run into. And in PyMongo, this is straightforward to solve, although I have to use a lot of operators, these dollar operators, to make it work. But I haven't found a good way in MongoEngine. And so I still find on balance that working with MongoEngine, even for this query, is better. But here's the problem. What this query is asking, you're probably thinking it looks right. It takes a moment to realize the challenge we're hitting here. What this query says is go to the cage and find me the cage with a square meters at least minimum size. That's totally fine. That works perfectly. And it says show me where there's a booking greater than checkout. And there's a booking, this should be greater than. That was almost an error. So where there's a checkout date past, equal to or past where I'm willing to check out for my snake. The problem is if I have, let's say, 20 bookings in this cage, right? I probably want to check one more thing, but I can just check it down more. We're going to have to do one more bit at the bottom. But the problem is, what if there's 2 bookings? One that starts way in the past, but the checkout is like 1 day later. And then there's another one where the checkout date is way in the future, but you can only check in way in the day before. And these are not the same bookings, right? There's a booking where the check-in date is before the check-in, and there's a booking where the checkout date is after the checkout, but those are not the same. You need to say there's an individual booking, not like some set of bookings where one matches one clause and the other matches the other. So the way you do that in Mongo is you say $ element match. I think it's lmatch. Something like element match is the description of the thing. So you can say both, it must have both of these. But I don't see how to do that in MongoEngine. It seems like it should be possible, but it certainly is possible for equality, but for these operators plus element match didn't seem to work for me. Anyway, if you figure out, feel free to use element match. I didn't, so I've got to add one more line here, and I'm just going to copy that over real quick, and we'll talk about it. So what we're going to do is we're going to say, let's go and actually, these are the cages we care about. I'm going to iterate over the query, which executes it here. And remember the cage, each cage contains a number of bookings. For each booking, I want to check that both the check-in is before and the check-in is after, and that the snake ID is none. So it's not already booked during that time. So if it's both available and the check-in, check-out date matches, then we can make that part of our final cage there, our final cage list. Okay, so, and it says it returns this, but actually what it returns is a list of cage. There we go. Okay, so that's what we got to do. If I could get element match to work with greater than less than in MongoEngine, this would not be necessary. You could just straight up run that query. But anyway, it's not a huge deal. Remember, this set is already filtered down to where significantly, right, where the check-in and check-outs do match. It just happens to be maybe one more thing is missing there. Okay, so we're getting the available dates. Let's come back to our guess here. We've got our available cages. Now we just have to show them to the user and let them pick it. All right, so let's just take some pre-written code for this. There are a certain number of cages available, and we're going to enumerate over them. And don't need the average rating right now. Do like this. So we're just going to print out the name, the square meters, whether it's carpeted, and whether or not it has toys. We don't want that to be true, false. Let's put that yes or no, more friendly, right? And if there's no cages, sorry, there's no cages. But if there are, we'll ask you which one, and we'll pick that out, zero-based, of course. And finally, the final thing to do is going to be book a cage, and then actually, we'll just give out this nice little error, this nice little success message saying, hey, you booked it for this time. So The last thing to do with this booking a cage is to actually book it. So let's go over here. PyCharm, write it one more time here. And now what we're going to do is we're going to loop over that cage's booking. So the way it works is they've selected a cage. They haven't selected individual booking. So we just have to go one more time over the bookings and go, let's find a booking within this cage, which we know exists because it's in the list, and let's assign it to the snake. So we'll do something like this. We'll come down here and we'll start out by sending this little booking to nothing, just in case for some odd reason we don't find one. We're going to go through and again do this similar test as we did right there, right? We got to find the available booking within the cage. We know it exists, but we got to find it. And then down here, we're going to just set a few things. Say the booking dot guest. You can get a little IntelliSense auto completion if you want. Set the guest owner ID. I guess we probably got to pass the account as well. We'll say account.id. Say booking dot set the booked date. It was booked right now, regardless of when the booking was. And we also need to set the snake. There we go. And then we got to go back and save it. But remember, don't call save there. We call cage.save. Okay, excellent. Now I think it just believes that's a misspelling, but I'm going to say it's not. All right, so that should let us book a cage. Woo, that was a tough one, right? So pretty interesting query. We're using the operators, greater than, less than. We're traversing the hierarchy. And like I said, we're sort of effectively in memory applying this element match. Element match works in MongoEngine, but I couldn't get it to work with both element match and the operators. So anyway, this will be fine. Come down here and given a cage, we'll pull out the booking. We probably could structure it slightly differently so we could skip this step and somehow capture the booking directly, but this is fine. It works plenty fast for what we're doing. Set the hey, you booked it values of the booking and call save. All right, I think it's time for us to test our book a cage. And I noticed I almost forgot to add this here, state.activeAccount, when I added it below. So let's go ahead and run this. We'll come in here and we'll be a guest. And let's go ahead and log in. And let's see our snakes. So we have these two snakes. Neither of them are venomous. Let's book a cage. I'm going to start by booking this. Now, how do I know that date? Because over here, we have 2 available bookings for the large boa cage, and these times 1 to 6 in January. So we'll go 2, let's say 2 to 4. Should be fine. Got this. Go to 4. And it says which snake. Remember, it matters the size of the cage and snake, as well as whether it's venomous. So we'll pick Slither. And hey, look, the one cage is here. Let's say, all right, let's book it. We've successfully booked the large boa. All right. Now, we haven't written view your bookings, but we do have that, I believe. We might have that for the other one. Go over here as a host, and we log in as Michael. I think we might not have implemented this as well. But we can list our cages. Yes, there we go. We can see that we have 2 cages, Bully's cage and large boa. And look at that one. Somebody has booked this slot for the large boa cage. Yes. So it looks like that worked successfully, just like we expected. All right, we're down to the very last thing we're going to do as a guest, which is to view our bookings. We were able to book a cage, but as a guest, we couldn't see, can't say, what are your upcoming stays for your snakes and things like that. So again, just for the sake of time, let me go over here and put some pre-written code, and we'll go write the data access layer. So require an account, and we're going to call get bookings for user. And this is going to return a set of bookings. And just to remind you what that looks like, the bookings are going to have the date, possible reviews, and the snake ID is going to be really important. So what we want to do is we want to say, give us the snake given a snake ID. And a super simple way for us to do that is to actually just generate a dictionary using a dictionary comprehension. So this little expression on here is going to create a dictionary where the key is the ID and the value is the snake for all the snakes belonging to us, whoever the logged in user is. And then we're going to get the bookings, and this is the part we're going to write. And then we're going to loop over here, and we're going to print out, hey, the snake, and we'll use the dictionary lookup to get the name here. We're going to print the cage name, and need to import date time there. I'm going to create a date time and do a little bit of math here on the checkout. So we're going to turn this back into days. You're checking in on this day for 5 days, something like that. Okay, so that's what our view bookings UI, that's pretty much a stretch, right, with our app, but that's kind of this is kind of the UI code, if you will. But we got to write this get bookings for user. This is going to be a bson.objectID. And what we're going to get back is a list of booking, I believe. Now, notice one other thing before we write this code. Over here, we're saying b.cage.name. Now, cages have bookings, but bookings don't have cages. There's not a super nice way to create that reverse association in MongoEngine. So what we're going to do is part of what we're going to do in this function is we're going to set up that relationship. And let's call this user ID or account ID, something like that. Okay, so the first thing we need to do is find the owner. So we'll call this account equals, let's pass in an email instead, something like that. And before I forget, pass in the email there. Okay, great. So we'll have our account, and we've already verified that they're logged in. So we can just assume that that happens. So we can say booked cages. And so we can find all the cages that have been booked by this person. So we can say cage.objects. And now we'll do a few other interesting things we haven't seen yet. Say filter. And here we'll say bookings, double underscore. And then we're looking for, let's see, the guest owner ID. Let's go to our booking. That matches the owner. That equals to account.id. We don't actually care about all the details about the cage, and you could skip this little part right here, but just as a means of efficiency, we can come over here and say only. We haven't talked about this yet. So what we can do is say we only want to get back 2 pieces of information, not potentially tons of information in this document. We want the bookings and we want the name. So when we say cage.name above, that means something, right? So let's create the bookings, and we'll do this with a list comprehension. So we'll say bookings is this. I'm going to write in one way, and then we'll have to make a change to do this reverse association with the cage. So I can say booking for booking in the booked cages. But remember, there are other bookings that are unrelated to us here, right? It could be 2 different snakes staying in the same cage, different days. So we need a little test. All right, so this is going to be the bookings that are assigned to us within the cages for which we have booked, right? So show me all the cages where we've booked at least one of the bookings, and then we're going to strip out the unrelated ones. So you might think that we're kind of done, and that we're very, very close to done, but we're not done. So if we run this, you should see this is going to crash because of that line right there. Now, I almost messed this up. So this is actually for cage into book cages, and each cage contains a booking. So we got to do a double loop here, booking in cage.bookings. Ooh. So what we're going to do is going to take this hierarchical list of cages, which nested inside them contain a bunch of bookings. And we're going to flatten that list with a double loop. Go through each cage, go through each booking, and just turn that into a list. And across all those bookings, across all the cages, only show the ones which we at some point have booked. Okay, so this is close, but if we try to run it, this reverse lookup of the cage here is not going to work. So let's see, we can try to run that real quick. Save. Go as a guest, log in as Sarah. Now if we try to view your bookings, see, no cage. So let's do one more little trick. We can do a transformation at this level, right? This is like the select part of the list comprehension. Now, this has to be an expression. And I don't think we can do this with a lambda expression because it doesn't allow us to make modifications. So we got to define this little local function. So I'll say map cage to booking. Given a cage and a booking, it's going to be the silliest thing you've seen. Booking.cage equals cage. Well, and then we're going to return cage. Sorry, booking. So why do we need that? We need that so we can come down here and we add this function. It's going to take a booking and it's going to put that same booking right back into the list, but the booking will be changed in that it's going to have a cage associated with it. Okay, so I know that's not super obvious, but that's what we need to make that one line work. Oh, I made a quick error here. I had booking cage here and cage booking there. So cage, booking, cage, booking. Okay, looks like it's ready. Let's try again. All right, let's view our bookings. Woohoo! It works. We have one booking. Our snake Slither is booked in the large boa on this day for 5 days. Let's add one more booking just to make sure this is working. So book a cage. All right, so let's try to book that other available booking. This time I'm going to put bully in there. And I guess we're going to book that one. Great. If we view our bookings again, we now have our snakes booked into the different sections at the different times. Let's just try one more time now that those bookings should have been used up to see what happens. So let's try to book one more cage. Say we'll start on that date. Let's check out on that date. And we'll use this one. Sorry, no cages. Both the available slots have already been booked. Just so happens to be to our snakes. Awesome. It looks like the guest side of things is 100% working. We just have one function left to write for viewing the bookings as a host. What bookings, available booking dates in your cages have been booked. And we'll be done with this application. So this require account stuff, paste that. That's the same. Nothing special there. Now we want to get the cages for the current user. Well, guess what? We've already written that. Find cages for user state.activeAccount. That's cool. So that was already done at some point along the way. And then what we need to do is we want to get the bookings and we want actually a flat list of these are all the available slots that people have booked across all the cages. All right. So what we're going to do is a thing called bookings like this, a list comprehension. And we're going to use sort of a dual comprehension to flatten it. So we're going to put something here, 1 and 2 things. I'll say what those are in a minute. So we want to say for C in cages. And then for each cage, we're going to say for B in C dot bookings. Now we don't want all of them, right? There's already a way to see that kind of stuff. But what we want is the ones that have been booked. And we know they're booked if the booked time or the book date was set. So say if B dot book date is not none. What do we want to get back here? We want to get the cage and the booking. So we're going to get a flat list of all the bookings, and along with it, we're going to carry along its cage that it came from. So that's pretty straightforward. And then that's this part, getting them as a flat list. And then the last thing to do is just print them out. And that's a lot of typing for not a lot of value. So let's paste that over. We'll import date time. And we're going to, as we loop over them, we're going to unpack that tuple. So the CB here gets unpacked into the CB right there. And we'll say, for this cage, it was booked on this date by so-and-so. All right, it looks like this is going to work. I have a lot of faith in it. Let's give it a try. We'll come over here. We're going to be a host. We're going to log in as me. And are you ready? Moment of truth. View your bookings. No, there's no duration in days. So where did this duration in days go? So this is the booking. Let's look at the booking real quick here. It has a check-in and check-out date. Let's add this duration in days. Now, if we add it as an actual thing that MongoEngine saves, that won't be so great because it's going to have duplicate data, check-in, check-out, and days. Like they could get out of sync. So what we're going to do is we're going to add a property. So we have a property called duration in days. So close. Days. Is that the same? Yes, duration in days. So down here, we just need to use the time delta to figure out what that is. So we'll say dt equals self.checkout date minus self.checkin date, and we'll return dt.days. All right, let's try to run this again. Oh, double ats. Come on. Too much help here. There we go. All right, come in as a host, log as me. Ooh, ready? View your bookings. Ta-da! Beautiful. And you can see our property is working just right there. So 5 days and 10 days. Now, remember when we actually we said we're going to book it. We could book it for a subset of time. We just don't store the data for how long the user said versus how long the time slot was. So they kind of get that whole slot, and that slot is worth 5 days and 10 days in duration. But given the data that we're keeping, this is working totally well. So I think we've done everything. We can create an account, log in, we can list our cages, we can register a cage, which we already did. We can update the availability, which is how we got these slots. We can view our bookings, which we just wrote, and we can even get a little help. We can go back to the main menu, and we could check out the guest just one more time around. Again, create login, same thing. It says book a cage. That's reserve a cage for your snake. We saw that we can add snakes. Oh, I got to log in as Sarah. She's the one with snakes. She has those snakes there. She can view her bookings from the perspective of her snake, not from the available slots, things like that, right? She only sees her bookings, not all the bookings across everything. And we can go back to the main menu, or because we're done, we can say goodbye to Snake B&B. Now that we've built our app, let's review some of the core concepts we saw along the way. If we want to insert an object, we just create a standard Python object style. We just say owner equals owner, call the initializer. We could either pass the values as keyword arguments, or we could say owner.name equals name, owner.email equals email. And at this moment, there is no ID associated with this object. But then we just call owner.save, and now the object ID or whatever the primary key is, you can set functions to be called when that happens for that generation. Whatever that's going to be, we've got it set after you call save. So now you can start working with it as if it came from the database. We also might want to insert a bunch of things. It turns out if you have 100,000 items to insert and you create one, save, create one, call save, create one, call save, it's a lot of database back and forth, and it's very slow. So what you would rather do is create a list of them. So here we have a bunch of snakes we want to save. We create a bunch of them, put them in this list, and then you call snake.objects.insert and you give it the list. And that's much quicker if you want to do a bulk insert type of thing. We saw that querying the database is pretty straightforward. The way it works is we start with the collection, the type that represents the collection we want to work with. And then we say dot filter. So here we're saying filter, and we want to do a match where the email equals the value of the email variable. And you could have more than one thing in here. You can have more than one filter statement, and those basically combine as an and. Now, this would return potentially a bunch of owners, but we don't want a bunch of owners. We want the one that we know matches this email. So we can say dot first, and it'll give us the one, or at least the first item to match. If there's no match, we get none back. We don't get a crash or anything like that. When we're querying against just plain straight fields in our object, that's pretty straightforward. We said email equals the value that we're looking for. But if we're looking deep inside of a hierarchy, it can get a little more, let's say, non-obvious. So we're combining two really interesting things here. We're going to the cage, and we're going to search within the bookings embedded document list, right? Bookings was a list, and it contains a bunch of these booking objects. So the first thing that we're doing is using double underscore to say bookings guest snake ID. So we're looking at the value guest snake ID of the booking items within that list. And we're also applying the in operator. So the double underscore in means the collection on the right, we're doing an in test for the various booking snake ID. So we use the double underscore to separate and navigate the levels in subdocuments, as well as to apply the particular dollar operators. And then what I consider a best practice is to fully execute the query before you leave this function. If we just return to book cages, it kind of still is not yet executed. It hasn't quite talked to the database. And so I want the database to be done and over with by the time we leave this method. So wrapping it in a list will execute all that stuff and pull it back. For super large amounts of data, there might be reasons you don't do this, but for most of them, I would do something like this. Now, sometimes you don't want equality in your matches. You want some kind of operator like greater than or less than or in or things like that. So here you can see we're going to the cage and we're finding all the cages where the square meters is at least the minimum size. So just like with subdocuments, we use the double underscore and the operator name, GTE, here to actually do this query, right? There's a bunch of dollar operators. You can find them in the MongoDB documentation, and you apply all of them in this way. Now, the other thing that we're looking at here that we didn't do in our app is count. So if we want to know how many cages there were, we could say do the query .count, and it'll just do a count in the database rather than pull all the objects back where you do a length of it or something like that. The most straightforward way to make changes to a document or to a record is to go get it from the database, change the class, and call save. So in this example, we're going to go get the owner out of the database, make sure that's all good, right? Don't want to have errors. We're going to create a snake. We're going to do work with the snake, and then we want to append the snake ID onto the owner's snake ID collection. So on line 11, we say owner.snakeIDs.append, and we give it this new ID that was gotten from the snake on line 9 when we called save, and we save the owner, and that's that. Right, so we get the document, we make a change to it, in the case of line 11 here, and then we just call save, and that pushes it back. This works, but that transfers the entire document out of the database over to our app, deserializes it, processes it, and then reverses that back to the database. That can be slow, but that can also have concurrency issues. If two people run this exact same method at almost exactly the same time with the same email address, there's a chance that one save is going to overwrite the snake IDs of the other, right? Both of them read the owner. One makes a change, one saves, the other saves. You only have one snake, not two. So there are challenges with this, but if you're pretty confident that that's not an issue you're going to run into, this is a really nice and easy way to do it. While MongoDB and MongoEngine let us work with these documents, make changes, and push them back in, there might be a better way. So if we know that we want to just change some small part of the document in a very controlled way, we might want to use some of the atomic operators. So here, let's suppose that there's a number of stays field, which is an integer, in the cage. So we just keep track of how many times people have stayed at it. Now, there probably are better ways to get this, but let's suppose that is a number and we want to increment it. So instead of pulling the cage back and doing a plus equals 1 sort of thing and saving it, we can literally go to Mongo and say increment this number, the value of number of stays, by 1. And that could be negative, that could be 10, but I have 1 here. So you write the query dot update 1 and then pass the little operator. So that's really great. Now, how about this putting the snake ID on the owner? Well, we can do that too. So over here, we're adding a snake. We generate the snake, we call save. That's standard, that's an insert. But then this line where we have the number of updated, we have owner, objects, emails, email, and then instead of saying, get it back, make the change, append it to the snake IDs and call save, we're doing something with an operator. So we're saying update 1, and we're using the push operator. That's $push. And we're going to push it onto the snake IDs collection. Another thing we might do, which probably makes even more sense, would be add to set. That's another related operator that will say, add this ID to this set or this list, if and only if it doesn't already exist. So you won't get duplicates, right? So we're pushing the snake ID on there. That way we never pull the owner back. These are atomic. They're perfectly fine in concurrent situations, things like that. So this time we have to check that we updated it in a different way, but the same effect as we saw before. So MongoEngine supports these in-place updates, array operations, and set operations. So like increment as well as push. And these are both better for concurrent safety. Think of them as basically transactional, and they're better in pure performance. So they're not always as simple to work with, but they are better if you can use them. There it is, the finish line. You have made it. Congratulations. I hope you've learned a lot throughout this course. We really have covered a majority of what you need to program against MongoDB. So you've done it. You've crossed the line. Now you know enough to start building applications based on MongoDB. So the big question is, what are you going to build now? I hope you go out and build something amazing. Please share it with me when you do. I want to take this moment to remind you to get the source code. Come over to github.com/MikeCKennedy/MongoDB-quickstart-course and star and fork this so you're sure to have a copy. So one thing I do want to take you through really quick, two things. One I covered in the beginning is there is the starter code, which is here. This is exactly what we started from. And here is what we have finished with. You can see right there, 15 minutes ago, I wrote final code. But I also wanted to make sure there were save points along the way. So if we go back here and check out the branches, you'll see there's all these different branches. So these are all different save points that you can grab. So if I go here, for example, you can see final, registered, and list cages. Guests can now book a snake into a cage and things like. So these are different points in the course that you can go back and forward to. So be sure to make use of the branches and things like that if that can help you. You learned a bunch of stuff to program MongoDB using MongoEngine, but there's actually a lot of other things that you need to take into consideration when you're doing MongoDB in production for real applications. So I want to encourage you to check out my paid course, MongoDB for Python developers. And just some of the things we're covering, you've seen a little bit of it, but there's actually a lot more. So this is over 7 hours of professional grade MongoDB and Python programming, not just MongoEngine, but the core PyMongo, the JavaScript API, and so on. So let's see a little bit of what's covered. So we talk in depth about how to set up your machine, whether it's Windows, Mac, or Linux, the tools that we're going to use, how to get them installed, why, the theory behind of NoSQL, why document databases, MongoDB's native shell and native query syntax. So when we run these operations, these queries, filter statements, and so on in MongoEngine, how does that map down to the database? This is important because when you're running MongoDB in production, you need to be able to use the tools and the query language to talk to it, manage it, right? And that is in this native query API. How to model data with documents. We did talk about this. We go into more depth in this course. MongoDB from PyMongo. This is the foundation of MongoEngine and basically the Python's equivalent of the native query syntax. MongoEngine. We covered a lot of that in this course, so this is pretty similar. High performance techniques, so performance around document design, performance around indexes, and using profiling to discover where you need those. So that's covered in this course. And super, super important is how to properly deploy MongoDB in production on the internet so it doesn't get hacked and you don't lose data or anything like that. So if you want to check out this course, here's a tremendously long URL that you very likely don't want to type. So type this, bit.ly/MongoCourse, and that'll take you right there. You can check it out. I encourage you to take this course. If you like what you saw in this course, here's 7 more hours going even more in depth. So with that, I want to say thank you. Thank you so much for taking my course. I really hope you learned a lot and you enjoyed it. Please connect with me on Twitter @mkennedy or various other places you find me on the internet. Thanks, and see you later.